Hey y'all, wanted to make a quick follow-up video on problem number 5 where we had to deal with scientific notation in both a numerator and a denominator position. So remember, for these problems where you're given some starting point, and in this case it's in terms of number of molecules, and they're asking for the mass, which is a macroscopic sort of term, the grams. We know where we're going. We're having to go to grams of our NO2. And we know that we have to start from our number of molecules or compounds, which is 4.78 times 10 to the 24th NO2. Then we know that we have to kind of connect by having two conversions. The way we know that is by looking at that sort of guide over here, that I know I have molecules, numbers of them, and I have to go to the bridge, the mole, then I have to go on to grams. If it had been number of atoms, it would have been 3 steps. To molecules, to moles, to grams, but it's just molecules. So I can go just 2 steps. So I know that if I'm going from molecules, numbers of them, to the moles, I have to divide by 6.02 times 10 to the 23rd to get to 1 mole of NO2. And to go from 1 mole of NO2, again, we're just kind of canceling the units. We have to be on the bottom. I have to go to the weight from the periodic table, 46.006 grams of NO2 for every 1 mole. So I just wanted to cover real quick what to do when you have powers. Just in general, what you can do is, and you set the 10 to the 24th sort of aside and set the 10 to the 23rd aside, and all the way to the end of the calculation. We know that we can subtract. If it's dividing, we can subtract. If it had been 10, if it had been multiplying, we add, but we're dividing, so this is equal to really just 10, or 1 times 10 to the 1. So we can just say that's 10. So we can really take this power separate from the number, this power separate from the number, and say, hey, when I work with those, it's really going to be whatever I get times 10. So I'm going to keep that on the top, on the numerator side. If it had been 10 to the 21st, then we'd have had 10 to the 3rd, because it'd be 24 minus 21 would be 3. And we have 10 to the 3rd, but 10 to the 1 is just 10. So we're just going to have a multiplication of 10. So you do your 4.78 times 46.06. So 4.78 times 46.006 times 10, it equals. Divide by 6.02, it equals. And you'd have your grams of NO2 that you need. Hope that helps, just how to deal with powers. Now, your calculator, I'll have a separate video on how you enter these into your calculator, but you can simplify the math if you have powers by setting them aside or considering them first, and we did, and we have just really the power of 10 on the numerator side, since 24 minus 23 is uno, and 10 to the 1 is 10. That's how we do it. Thanks, bye-bye.